Okay, so for the next video in this series, we're going to look at various government interventions that impact prices in the market and look at the repercussions of those interventions. So let's start with a price ceiling. That is when the government sets a maximum allowable price for sellers. They're not allowed to charge a price that exceeds the price ceiling. So first, let's start with a market that does not have any sort of interventions. So I'm just going to draw sort of our standard partial equilibrium graph where we have downward sloping inverse demand. And upward sloping inverse supply. And without any sort of an intervention in this market, the equilibrium is given by the intersection of the inverse demand and inverse supply curve. So we can trace that over to the vertical axis, and that gives us the price in equilibrium without any sort of government intervention. And if we trace it down to the horizontal axis, that gives us the quantity in equilibrium without any sort of an intervention. Now let's assume that the government introduces some sort of a price control, a price ceiling, setting a maximum allowable price that these, whatever market that these goods can be transacted for. Okay, let's call this the price ceiling. Right here. Okay. At this lower price, demand is higher. That is, more consumers would like to buy the item at this lower price. So let's mark down the new amount demanded with the price ceiling. Unfortunately, many of these consumers cannot actually buy the product because many sellers are no longer willing to sell at least as many items with the price ceiling. And if we look at this point here, any units that are further up and to the right on this inverse supply curve correspond to units where the cost of producing them is greater than the price ceiling. So firms would actually lose money by producing these units. So they're not going to produce them. So the quantity that's actually supplied in the market is given by this point on the horizontal axis. So this is the quantity supplied with the price ceiling. Okay, so we can see that demand exceeds supply. And that raises the question, who gets the product? If there's more people who want it than there are items or in the marketplace. Usually, and what we'll assume for this class is we'll assume that consumers who have the highest value for it, that is, consumers on this region of the inverse demand curve, get the item. And so you can basically trace this down. Okay, so it's once again, it's consumers in this region who gets it. Now that's a simplifying assumption. That may not necessarily make sense. If you think about for some items like concert tickets, who gets it? It's not necessarily people who are willing to pay the most in dollars, but it could be people who are willing to wait longest in line, who have the lowest value for their time, or some combination of high value for the item and low valuation for their time. A lot of people with a lot of money, often who are working extremely hard, think of an investment banker working 80 hours a week, they have a very high value for time. And so they're not going to pitch a tent and camp outside for 3 days in order to get the tickets. Okay, so this assumption that we make that those who value the item most are the ones who are awarded it may not necessarily be reflected in reality, but it is an assumption that we're going to make. We're going to ignore other costs of sort of being allocated an item. Clearly, consumers who have to wait in line for 3 days, the waiting in line is of some value to them. There's a opportunity cost of their time, and so that is some cost that they actually incur for being allocated the item. Other people pay bribes. We're going to ignore those types of costs, the cost of waiting in line or bribes. We're just going to assume that somehow magically those who value the item most are the ones who are allocated the item when the amount demanded exceeds the amount supplied with the price ceiling. Okay. So let's look at this. So if this is the number produced, we can see that there is some area here, this triangle here, shown in orange, that represents the units which would be efficient if they were transacted. Like we could take one example right here. So here's an example where the person at this point on the demand curve values it more than the minimum willingness to accept, the lowest price that the supplier is willing to accept. So that would be an efficient transaction. Okay? But that transaction only happens if the seller is allowed to charge a price above the price ceiling. With the price ceiling, that transaction does not take place, and so that contributes to the deadweight loss, the inefficiency of this government intervention. Okay, so there's this orange area here. Now, what's interesting is that even though there's a deadweight loss, it's not clear whether consumers are better or worse off. Consumers actually might be better off with this intervention. Okay, so here I've illustrated that graph in a pre-made diagram. So here we have the inverse demand, inverse supply. The light green area reflects consumer surplus when there's no government intervention, and the light blue area represents the producer surplus when there's no government intervention. So now we're going to add the price ceiling, okay, and it's going to reduce the amount that's supplied in the market, leading to this deadweight loss area, this purple area that I was referring to a moment ago. A few moments ago, I had drawn it in the picture as an orange area, but in this graph, it's a purple area. Now, that's not the only thing that happens. Okay, so that does lead some consumers to be worse off, but the consumers who are still able to get the item, they're able to get it at a lower price. And so that increases the consumer surplus that those consumers get, which if that increase in this green area here is greater than the loss to consumers, or the portion of that purple area that's a loss to consumers, then in aggregate, consumers are better off. Now, ignore the fact that there's some allocative issues. Some consumers are better off because they're able to get the item at a lower price, whereas other consumers are worse off because they no longer get the item. Ignoring that, we're assuming we can sort of add surplus across consumers. In that case, it's still possible that a price ceiling makes consumers better off, unless it's too stringent, which is something that we're going to consider in class. There's one more thing that I want to do. I want to quickly highlight these areas that represent the changes in surplus to consumers and to producers. So let's take a look at this graph here. So here I've marked these different areas with letters. So this green area here is represented or is equal to A. So we're going to say this area is equal to A. This light blue area here in this deadweight loss portion, that is area C, and so on. So the question, and you can sort of pause the video for a second and think about it, is what is the change in consumer surplus? Okay, so the consumer surplus before the government intervention is equal to areas A plus C. Afterwards, the consumer surplus is equal to areas A plus B. Right? Area B reflects some consumers getting the item at lower price, and area C, or the loss of area C, represents some consumers no longer being able to buy the item. So if you take the difference between those two, the change in consumer surplus that results from introducing a price ceiling is area B minus area C. And depending on which of those two areas is greater, that will determine whether in aggregate consumers are better or worse off by this government intervention. Now let's look at suppliers. The change in producer surplus, if you look at it, is minus area B minus area D. So before the government intervention, producer surplus is area E plus area B plus area D. After the intervention, it's just area E. And hence the change is minus B minus D, showing that producers are made worse off by this price ceiling. And if you add the changes in surplus to consumers and the changes in surplus to producers, you get that the total change in surplus is areas C and D. It's a loss in surplus equal to the sum of areas C and D, which is the deadweight loss area that I illustrated previously. Okay, so as I said, we're going to look at this in greater detail in class. I'm going to have a number of examples and then some tougher questions related to some of these different items.